Okay, everybody, this is Chip Crotty from Cocoon. I'm a little technical difficulty here. I don't see anything, so I'm going to go through what I think you guys are hearing and seeing. I see that there's several people in the chat room. I think they're all ADS people, so good morning, everybody. Thanks to ADS for putting this together. I know it's a big effort, and I know there's going to be glitches, all fully understandable. So Cocoon Inc., if you don't already know who we are, in fact, is there anyone in the chat room that's military? Is it all ADS? So I know how to direct this. Okay, well, I'll start. So a couple interesting facts for you guys in case you don't already know them. 1.15 million non-addressable days is due to corrosion in the military. So that's a pretty big number. That 1.15 million days is 3,100 years of non-addressable days. 3,100 years ago, it was 1080 BC. So just a few little facts I thought you would enjoy. Corrosion costs the DoD $20 billion per year, and $20 billion per year equals $55 million per day, or that equates to $39,000 per minute. So you can see that's pretty big number for the military to deal with, and that's really what Cocoon is all about. So we put our products and services together to help reduce the impact of that big corrosion cost. And in doing so, we increase readiness, we decrease maintenance costs, we extend useful life. And kind of the big thing for us is you can't fight Mother Nature, so you have to outsmart her. So we look at ways in our product mix and the things that we do as ways on how to outsmart her. So I thought I'd introduce a few of those things to you. We were trying not to do death by PowerPoint. However, I'm not quite getting how to do some demos, so I'm going to go the best way I can this way if it's okay with you guys. So moisture degradation impacts readiness in the most difficult ways, but a couple things for you to know that will make you really smart in this world and get you promotions if you understand these things, and you'll know how to go about solving these things. So mold and mildew is considered corrosion, and it starts at 70% RH or higher. Softening of packages, it starts at 55% RH or higher, and it's a big problem, by the way. Softening packages in storage, all the cardboard collapses, creates all sorts of problems for the military. Rough corrosion on steel is what we're all familiar with. That starts around 50% RH, and electronics starts around 40% RH. What I wanted to show you is by maintaining less than 35% relative humidity, you prevent all of those problems from happening. Corrosion, by the way, is a big word in the military. It's not only moisture-induced corrosion, which I just showed you, but it is sand and dust. So that sand in theater is 1 micron. We refer to it as moon dust. It gets into everything, and it causes all sorts of readiness and equipment problems. Sunlight, UV degradation is considered corrosion. Airborne pollution, salts and chlorides, landing on things is considered corrosion, and extreme temperatures, believe it or not, is considered corrosion in the military. So we take all those things into account as we're designing our products and services. This is what a corrosion problem looks like. So to the left, if you guys can see this, is a container. That shipping container was maintained by that gentleman, the shorter gentleman there, and traveled the country to support some training. He took absolute care of what he got, and that's what the inside of his container looks like. The middle of the pictures are showing what we call parts storage containers. They're all over. There's thousands and thousands of them. They put very high quality assets or expensive assets in it, lots of aviation stuff. They open it up and things have gone bad. And of course, to the right is what a vehicle looks like in mold and mildew and in storage. So those things we try to take care of. Storing things in less than 35% relative humidity is considered stopping the aging process. So NAV Air has something they call level 3 aircraft preservation. That's storing their aircraft in humidity control. If an aircraft goes in that's 2 years old, stays in a humidity controlled environment for 5 years, it comes out 2 years old. So that's called stopping the aging process. So every branch in our military does this. They just call it different things. The Army calls it APS, Army Preposition Storage. Maritime Administration calls it Military Preposition Storage Afloat. The National Guard calls it CHP, Controlled Humidity Preservation. So it's all storing things at less than 35%, and doing that, they get the effects that we were just talking about. So we employ that, and I'll show you how we employ it. So this is what corrosion-free storage looks at sea. And this is where we started as a young company. These ships are commercial ships chartered by the Military Sea Lift Command, but we also do gray ships. These ships go to sea for 5 years at a time. So by maintaining less than 35%, all the cargo on those ships stay in readiness condition. So that's a real interesting expertise for us to have. We're able to create these environments on ships and on shore, and we're able to monitor these things from our office no matter where they are in the world. This is what corrosion-free storage looks ashore. So the bottom picture is a series of containers. This is Savannah, Georgia. This is called Class 9 aviation parts. Those containers are representing about $30 million worth of part storage. And on average, they lose 20% of that annually. We put up the building that you see in the upper right-hand corner. This one is 60 by 150. That whole building went up for less than $1 million. Their return on investment was 5 weeks. So they went from losing $30 million a year to $0 million a year. That's pretty significant. And this is what it looks like for pre-positioned storage. So this is a building that's represented parking 266 vehicles. This one is 130 foot wide by 600 foot long. We're about to do something at Marine Corps Logistics Command in Albany, Georgia. That's 200 foot wide by 500 foot long. Will be all humidity controlled storage, and we'll be remotely monitoring it from our sites. So their payback could literally be in a year for an entire facility that large, depending on what we're able to do for them. Oh, thanks for the comments, guys. Corrosion-free storage of aircraft. So this is also what it looks like for aircraft. This facility is representing something that we're doing that's insulated, and this is in the hot zones, so that we have to protect from temperature and humidity. And then we monitor this from our location also. So this represents a building that's 233 foot long by 110 foot wide. So imagine us controlling that entire environment. And remember, it's called stopping the aging process. So this represents taking aircraft, putting it inside, and having the aircraft come out at the same age when they're done. Why that's so important to the Air Force or Navigator or whoever's doing this work, it means that they cut their maintenance down radically. So they are now able to protect their high value assets for as long as they need to, and they don't have to keep dumping money into it. And this is what it looks like for earth-covered magazines. We're just finishing designing these systems, but we're able to control the humidity in every one of these earth-covered magazines, prevent the corrosion problems they're having to the ammo that's stored there, and encryptedly remote monitor it from our office to prevent those problems. So that is corrosion-free storage. That's taking an environment that already exists and controlling the inside of that building so that it's less than 35% RH. If there's no existing buildings or earth-covered magazines, we'll literally put up the facility and create the environment. However, if you can't store things inside, then you're storing them outside. And so the next best thing is to cover it. So we have now designed, with the help of GE Energy, a new textile that works well outside covering equipment. And I'll show you a little bit about what that's all about. So this is what we call a blue tarp problem. So you're all familiar with covers, or you may be familiar with covers, but taking a cover, putting it over something, coming back to that something, say your grill at home, and you find there's mold and mildew and bugs under there. So that's what's called a blue tarp problem. That's trapping in heat and moisture and creating a greenhouse effect in its own corrosive environment. So our mission as a company was to prevent that from happening, and I'll show you some things on how we did it. So this is representing a textile. This is a 3-layer textile. We worked with GE Energy a long time ago to make this thing happen. It's a patented process. If this was my little demo, if you guys can see it, I have no idea. But there's air down here and there's water up here. And if you see me pumping away, you're seeing air bubbles go through that. So why that's really important and why that's a unique technology, it's allowing heat and air to escape naturally. This is so effective, it's almost as if the cover material is not there. So that's the basis of what makes the textile so effective. But in addition to that, it has many, many other features. The textile is considered hydrophobic. So that means its wet weight is dry, it's equal to its dry weight, so it won't freeze or won't get extra heavy. It is inherently anti-static, so it won't take a static charge. It's oleophobic, so it can be washed. It's anti-scratch, so it won't scratch the windscreens of aircraft that we're doing, and it's extremely durable. In fact, there's a test out there for wind whipping for flags, interesting enough, and we passed that test. We test to 110 mile per hour wind whipping on the deck of something or out in the environment. So our covers are employed in all sorts of vehicles now. So you're seeing rotary wing, you're seeing vehicles, you're seeing weapon systems, ground support equipment. This is what covers look like today. We spend a lot of time designing covers with the operator to make sure they fit and they function the way they have to. This is where we're taking it. So this is what we're calling a smarter cover, and we're working on this right now. So we're looking at new ways to shape a cover for certain equipment so it operates or it covers in a certain way. One of the things that happens to us, we show up on a site, we're starting to cover a strike car or an MRAP, and we find that they give us a model to cover and there's all these variations of that model. They've added antennas or blast shields or new electronics to it. So the cover needs to get changed all the time. So we're looking at a cover design that can scale for that model for any variations of that model. In addition, we're looking at ways to control the inside of the vehicle. So the inside of the vehicle, as you guys know, is full of electronics and other things that are affected by moisture degradation. And we're in the midst of designing a very low power, maybe solar generated small dehumidifier that will be powered by, you're seeing, we're representing some solar panels here. And in addition to that, we're looking at how to monitor the health of the batteries of the vehicle. So that parking vehicles all over the place, when they're in parking or storage, battery is a real problem for the government and it costs them a fortune. So one of the things we want to be able to do is monitor the battery health, charge it when it has to be charged, and report back when they have to be replaced. In addition to all those features, we now have the capability to remotely monitor every single piece of equipment we have out there encrypted and report back and say, hey, we need to take some action. And in fact, we're doing Special Operations Aviation 160, we're doing their entire regiment of corrosion-free storage and their parts storage. So keeping this picture in mind, this is what it would look like. We'd be in a field of vehicles like this. We would cover it with that new smarter cover, we'd monitor it from our location, and we'd be able to report back and say, that vehicle is having a problem, let's go fix it. And of course, we want to take on this type of environment. So think about Cocoon able to cover these things, protect them the way we're talking about, track them from our office, service them when we need to. Think about that will do for improved readiness, reduced maintenance, and life cycle extension. It's a big deal. And we're pretty close. We think we're going to be fielding most of this next year. And by the way, with ADS's help, and thank you ADS, we are now about to cover 1,000 vehicles in Germany to start this, not particularly this program, to start covering. And then we're looking to bring these features into that program as we go along. So that's our protective cover material. We've now taken that textile and we've built it into what I'm showing you on this screen is the thermal acoustic blanket for a Chinook helicopter. So remember we talked about corrosion and Mother Nature. One of the problems that a Chinook helicopter was having is you're seeing to the left, their current insulation product is 40 years old. It's falling out of the aircraft. It traps in heat and moisture against the aircraft skin and causes corrosion. So we took all of those features that we just talked about on our textile and added acoustic thermal capabilities to it, improved its performance, and along the way we saved about 160 pounds per aircraft, which is quite significant. So we've now solved the corrosion problem, solved the mold problem, improved the performance, and solved the weight problem with all that technology. And we're now looking at other airframes to do that. Big deal. We're getting lots and lots of good coverage from that. So that finished us off with our textile. Remember, we talked about creating environments if environments weren't existing, so buildings or rooms, earth-covered magazines. So that's given Cocoon a really expert knowledge in fabric buildings. So what I thought I'd show you is what a fabric building looks like to sort of pique your interest, and depending on what your responsibilities are, or who your customers are at ADS, this is another way to solve something. So this is representing a hangar that is in Edwards Air Force Base. We've done 7 projects for them so far. When you build at Edwards Air Force Base, you have to build, or anywhere that we build, you have to build to International Building Code. Edwards Air Force Base happens to have the highest seismic load in the country. So to build there is really significant. And I'll show you some things as we go along. So this is a 220 by 200. We did 2 side by side with a full fire suppression system. This was operational in about three months from the time we landed on site. This is also went through equipment dollars, just to let you know, so they were static by that. This is what a hangar looks like at Yuma, Arizona. Again, for our special community, this is 125 by 133. This hangar was constructed by the Corps of Engineers in Red Horse. And after they had their experience with this, they were so interested that they took us to Niger, and we put 3 hangars up there in Niger, and that was through ADS again, and they constructed that with our SME. We've been to Afghanistan, Iraq, you name it. These structures are now going out around the world. They're built to International Building Code. However, they're designed to be relocatable. So that gives lots and lots of flexibility deciding what they're doing. So they can go up for 20 years, maintenance free. If need be, they can be taken down and moved around with some effort. This is what a commercial hangar looks like. This is 300 foot wide by 300 foot deep times 2. I don't know if you can see it, but in the front of that, you're seeing a speck of a person. That's how big these things are. Full building code again, fully insulated. This is what it looks at sea. This is where we started as a young company. So we have pre-positioned storage, ships going out to sea. The thing that makes this remarkable is think about building fabric structures on the deck of a ship. Think about what the movement of a ship is and what a ship experiences, and then think of all the climates that it goes through depending where you're at. So these go to sea at 5 years at a time. Inside of those ships carry military products. Your upper left is ammunition. Your bottom right is secret squirrely stuff. Your upper right is aviation parts, and your bottom left is a MASH, a hospital unit. All of that has to be in ready-to-go condition when they need it. We've never had a failure. So that's hangars at sea. This is hangars ashore. This is Southwest Airlines down in Atlanta, Georgia. So this is 250 by 210. We're in Atlanta, Georgia. Think about their International Building Code means that we have to pass hurricane tests. So this passes the highest hurricane test in the country, which is Miami-Dade County hurricane test. Yes, make sure you leave time for Q&As. They're sending me messages. Okay, this is representing what we're doing for sunshades. So we're now taking on sunshades and looking at new ways to do it, to bring solar to it, and to do all sorts of other things. This one, to let you know, is interesting. This is in Greenland. This is designed, it was flown in. They have 120 inches of annual snowfall, so it's designed to tow. So you tow it above the snow load. So anyways, that's Mother Nature, and that's how Cocoon fights Mother Nature. So I know I said we talked really fast, but I thought, what the heck, go for it. So if you have any questions, I'd be glad to answer them.